We will see another example of multiple bodies when they are connected with some connectors which we have already discussed. For example, this is a configuration where again there are three walls, means two walls and a floor, and here this bar AB is having two ball joints at both its ends, and this end at A is inside a ball and socket joint. That means here a socket has been built inside the roof, the floor, and then the ball has been put inside that. That means this rod is freely, this can freely now rotate about point A. It cannot come out, but it can freely rotate about that. Now the other end, which again is a ball end, but then that end is resting on taking support on both the walls, on this vertical wall and this vertical wall. Okay, and the mass of the bar is 200 kgs. Okay, and the problem asks you to find out the reactions from both these walls plus the reactions at the socket. That means how the walls are reacting to this support or the mass being supported there, and how the floor is reacting. So that those are the things which need to be determined. Okay, now as usual, always we should do a create a free body diagram where suppose I'll draw like this. Okay, suppose this is our body AB, A and B, and now let me write it here. We'll have to, because we have removed it from now the complete structure, we have to compensate it for the forces which were coming from those connectors. Okay, now imagine this ball and socket. It's free, so it cannot exert any moment about any of the axes. Okay, when I am saying axis, let me first draw some coordinate systems. For example, say I am taking this, sorry, I wanted to be on the okay, so this being x axis and this being I wanted to draw like that maybe. Okay, so this is y and sorry, and this is your z axis. Okay, if that is the axis system which we will use, then what kind of forces do you think will come as reactions from the ground? See, again you ask the same question to the bar, that if I turn you around the point A, will you feel any reaction from the ground? The answer is no, because it's free. So there is no moment. Then you ask, if I move you at point A towards the x axis, will there be a reaction? The answer is yes. So then you should start putting the say in this direction, say AX. Okay, then y is in this direction, so maybe this is AY and this is AZ. Okay, so now these are the reactions which will come from the ground. That is the socket which is sitting there. And then what about B? Now the B point is also a bit tricky, that there are two walls which are joined to each other at 90 degree. Now they can never put any moment, so they can never try to rotate this bar AB, right? So there will be no question of any moment coming as reaction force. So only two, and then similarly in z direction it's frictionless, so there is no reaction which can come. So only which you have is say B, Y and B, means C. One in this direction and the other is in this direction. Okay, so BY and BZ. Say suppose I call like this, you know. Sorry. So this is BY, and so is this parallel? No, this should be parallel to this, you know. Sorry for that. This is in y direction. I have taken this as y direction. So in fact this should be by, okay, and bx is parallel to this, so bx. Okay, so these are the forces which will act, and if you wish you should be able to draw the axis, you know, like that. And yeah, so these are the axes x, y and z. So this is x, this is y, and this is z. Okay, so now how do you think you should figure out what, so and then we are supposed to find out what bx, by, sorry, bx, by, ax, ay and az. These 5 unknowns we have to solve for. Now best way to do is, as usual, take the moment about the point where maximum number of unknowns are passing through. For example, here this point, if I consider, 3 unknowns are passing through that point. Now if I take a moment about that point, then that should give me, I mean, that will get rid, by that we can get rid of 3 unknowns, and we will have only 2 unknowns in that equation. Okay, so for that what are the lengths? So this is 6 meters, this is 2 meters, this height is not known, so this height, suppose I call it h, oh, sorry for this color, say suppose this height is h. Okay, so this you can figure out, this will come out to be 3 meters. Okay, h will be 3 meters, because 6 squares plus 2 square plus h square should be 7 square, right? So 6 square plus 2 square plus h square is equal to 7 square. So if you solve this, you will get h to be 3. Now if that is so, okay, actually one more thing I forgot to put it here, and that's the weight, you know. So the weight is somewhere, it should act like this. Okay, now this w is nothing but that 200 times g, right? So that's the weight which is acting. Great. Then what? Now, and then this is a known thing, so we have to figure out what these forces are. One very important point which needs to be observed is, this point should be, anyway it's a uniform bar, so its CG will be at the center, and then if you draw, you know, a perpendicular to meet on the ground, so it will be halfway through all these lines, right? So in fact, you know, so this distance will be 1 meter, because this is 2. Similarly, this distance will be 3 meters. Okay, I think the colors are too bad to be visible. Okay, so if I drop a perpendicular here, so this distance is 1 meter and this distance is 3 meter. That's what I'm saying. Okay, so this being the center of mass of the bar. Okay, good. Now, how to calculate the moment of all the other forces about this point? So, you know that we always do R crossed with the force, right, to get a moment. So, now moment of the force W about O is equal to, say, let me give this point, say G. Okay, so this will be, this R is from A to G and F is W times minus K. Okay, so now let's see. Now this will be, how much is R? For R vector you have to write in this way, right? Let me put some, which color? Yeah, let this color. Now this is the, sorry, this is the color which I am trying to, this is the arrow which I am trying to find out. This is R, maybe AG. Okay, how do you find that out? So how much you go in the negative x, negative y direction? By minus 3j, right? So you go backwards in 3 meters. So because this is 3, so this also is 3. So 3 meters you are going backward in y direction. So minus 3j. And you are going up how much? This height also will be half of this 3. So because this is 3. So 1.5. So plus 1.5k. And how much we are moving? In x direction we are moving 1 unit, because this is 1, so this also is 1 in negative y direction. So minus I, right? So this is your R, and crossed with, let me move this thing here. So, okay. So let me draw that here. MO I had written, that's fine. So now what should I do? In fact, this also is gone. Yep. Okay. So this was our x-axis. Now this crossed with F. F is what? W times minus K. Okay. So that is one moment of this W about O. And what about the other one? Similarly, you can calculate, the moment about O of the reaction at B. Okay. Now, how do you calculate that? So that will be, R AB crossed with, say, BX I plus BJ, BY J, right? And then these two are unknowns. And what about RAB? Now RAB is this, which will be equal to what? Similarly, in x direction, how much do I have to go? Minus 2I. Then in y direction, I have to go minus 6j, and plus 3k. So this is RAB crossed with bxi plus byj. Okay. Now these equations, now the final equation which you need is this plus this to be 0. So that means you have to do m o of w plus m about o of the reaction at B. So that should go to 0 because everything is in equilibrium. Now if you get that equation, you will come up with okay, you will come up with okay the equation which will be something like this. It will be a vector equation, and once you solve them you should get Bx to be equal to 654 newtons and By will be equal to 1962. Okay, because that's a vector equation, so it will be actually 3 scalar equations. If you consider, see this one, if you expand, you will have something times I plus something times j plus something times k is equal to 0, because this is a vector equation, right? So this equation separately will go to 0, this goes to 0, this goes to 0. From there you will be solving for Bx and By and you will get these things. Okay, and now if you use summation of Fx equal to 0, from there you will get Ax to be, Ax to be 654 Newton. Similarly, summation of Fy equal to 0 will give you 1962. Again, Ay equal to 1962 Newton, and similarly Az is equal to 1962 Newtons. Okay, so summation of Fz equal to 0. So either you think in this term or you just say that okay, equal to 0. So basically you think in this and then you get a single equation, from there you get the scalar equation separately. So that is how you get these unknowns which were required. Okay, 3 reactions from the ground and 2 reactions from the walls. Okay, so if you see the important points, so the important points are how to calculate these R's. Okay, so I'll say this RAG and RAB, then how to represent in terms of F, nothing else. And watch out, the most important one was to think about how these reaction forces are to be written. Which are the reaction forces which will be involved, and then once you figure that out, that means the free body diagram, once the free body diagram is there, then the rest of all is just going back and writing the basic or spatial vectors. We had read under that name the spatial vectors. So you do that and then you are done. Okay, so let's see, we will see in the next segment another example.